Hey everyone, and welcome to this Field Log Explainer. I am so excited about today's journey. As a marine biologist, I'm going to be taking you along on an expedition to uncover the hidden, honestly almost alien creatures of the deep ocean. You know, it's so easy to look out at the sparkling blue surface of the sea from a beach and assume we know exactly what's going on down there. But the truth? The truth is that the vast majority of our planet's living space is actually this dark, freezing realm that we practically never get to witness. I want to kick things off with this observation because it really perfectly sets the tone for what we're about to do today. We are completely leaving the sunlit shallows behind to explore an alien world right here on Earth. Just think about that for a second. 90%. That means the bright coral reefs and the bustling coastal waters we usually think of when we picture the ocean, they're just a tiny, tiny fraction of the whole story.
Now, to access this dark universe safely, we absolutely need a technological lifeline. Enter our trusty robot, ROV Sebastian. Sebastian is a remotely operated vehicle roughly the size of a small minivan, and we operate it via a giant tether from our surface vessel way up above. The intense logistical challenges of operating remote vehicles in extreme zones like this are just wild. Picture this. We have to precisely maneuver this heavy piece of equipment from a ship that's constantly bobbing on the surface waves, sending it thousands of meters down into a freezing void, all just to shine a spotlight on the deep.
Sebastian is actually depth rated to 4.5 kilometers. That is a staggering depth, and it takes an immense amount of engineering to survive that descent without, well, imploding. Literally every single camera housing, every motor, and every buoyancy module has to be meticulously crafted to withstand the drop.
Okay, let's map out our descent from the vibrant surface down into the formless void. We start in the epipelagic, or the sunlit zone, which only drops down to about 200 meters. Next, we fall into the mesopelagic, the twilight zone, ending at the 1 kilometer mark. And finally, we plunge into the bathopelagic, the midnight zone, stretching all the way down to 4 kilometers. So keep this spatial structure in mind. It's essentially our expedition map, tracking exactly how far from the sun we're traveling.
All right. We've officially crossed the 200-meter mark, which brings us to Section 1, Deep Camouflage, Masters of the Gloom. We are now in the twilight zone, and down here, there's just barely enough downwelling sunlight left to cast a deadly silhouette.
It is absolutely fascinating how these midwater predators change their cloaking strategies depending on how deep they are. In the twilight zone, animals rely on silvering and transparency. They literally use these highly reflective guanine crystals on their skin to act like vertical mirrors, which makes them practically invisible from the side. But as we drop deeper into the midnight zone, that shiny, reflective skin would catch the spotlights of bioluminescent predators, so the strategy completely shifts. The silver gives way to ultra-blackness, utilizing light-absorbing melanin, and they start emitting red bioluminescence, which, incredibly, is practically invisible in the pitch-black depths.
The crucial takeaway here is that surviving the twilight zone's dim lighting requires some incredibly creative biological cloaking devices. We're talking counter-illumination, where creatures literally produce their own light on their bellies to perfectly match the fading sunlight from above. Then there's transparency, like the completely see-through glass octopus, and we even see decoys, squids releasing these ghostly pseudomorphs made of ink to confuse anything trying to eat them. It is a high-stakes 3D game of hide-and-seek. But you know, the Twilight Zone isn't just this closed-off, isolated world. Every single night, it hosts the diel vertical migration. Just wrap your head around this number. An estimated 5 billion metric tons of organisms rise to the surface to feed. It's literally the largest synchronous migration on Earth. Under the cover of darkness, deep-sea predators can safely exploit the energy of the shallows, gorging on plankton and smaller fish, before retreating right back down into the gloom before dawn.
Moving right along as our ROV plunges past the 1 kilometer mark, we leave the twilight zone behind entirely. Welcome to Section 2, the midnight zone, pitch black void. We are now in a freezing, completely sunless place where the rules of biology are pushed to their absolute physical limits.
To really grasp the sheer hostility of this environment, consider the pressure down here. 400 atmospheres. To put that into a perspective you can actually feel, that is roughly equivalent to the weight of 50 jumbo jets pressing down on you all at once.
So, how on earth do animals survive these crushing daily challenges? Through some extreme physical adaptations. To cope, these organisms have dramatically slowed their metabolisms. They've evolved strengthened protein structures just to keep their cells functioning under the weight. And perhaps most surprisingly, they utilize soft, gelatinous, uncompressible bodies. Because water itself cannot be compressed, animals like the famous, adorable Dumbo octopus manage to thrive here simply by being mostly made of water.
Another wild thing down here is that time just ticks slower, which allows for a phenomenon known as deep-sea gigantism. Certain incredibly patient predators can reach massive, ancient proportions compared to their shallow water cousins. Take the Greenland shark, for instance. That thing can grow up to 7 meters long and live for centuries. When your metabolism is at a crawl and you live in the freezing dark, you can definitely afford to play the very long game.
But of course, playing the long game still requires fuel. So let's enter Section 3, A Starved Void, to talk about feeding in the dark. Down here, there's obviously no sunlight, so there are no plants. The primary food source is just a gentle, continuous shower of dead organic debris falling from the bustling zones up above, something we call marine snow. Because energy is just so incredibly scarce, swimming around actively chasing food is not really an option. Instead, predators rely on highly specialized feeding tactics. The gulper eel uses opportunistic gulping, deploying these huge expandable jaws to swallow prey way larger than itself in one go. The comb jelly uses a sit-and-wait strategy, deploying sticky collar webs to just passively trap drifting food. And the anglerfish also sits and waits, dangling a bioluminescent lure to bring the prey directly to its mouth. Down in the midnight zone, conserving energy is just as crucial as the hunt itself.
Thanks to our ROV technology, we also get to reveal siphonophores, these entities that completely defy our standard definition of what an animal even is. These aren't single creatures, but drifting colonies of cloned genetically identical zooids that mutate to take on very specific tasks. Some act as feeding polyps, others as swimming bells, and others as floats, all working seamlessly together as a single organism. In a world without solid surfaces, these bizarre gelatinous structures, some of which reach an incredible 150 meters long, act as giant, living, floating nets.
Now, finding a meal is hard enough, but finding a mate in this massive, pitch-black void is nearly impossible. Which brings us to this mind-blowing biological workaround, parasitic mating. When a tiny male anglerfish finally manages to locate a giant female by tracking her species-specific pheromones, he literally bites onto her and fuses permanently. Their circulatory systems combine. I know, it sounds super extreme, but it absolutely guarantees reproductive success in an environment where you might literally never encounter another one of your species ever again.
To really wrap your head around the broader ecosystem down here, think about a relatable metaphor, comparing a sun-bathed forest canopy to the deep-sea floor. In a forest, the canopy produces all the energy, and the falling leaves support the detritivores scurrying around on the dark forest floor. In the ocean, the sunlit epipelagic zone is our canopy. The deep sea relies entirely on that biological rain, the marine snow we talked about earlier, drifting down to sustain the scavengers waiting at the bottom.
And finally, after miles and miles of empty water, our expedition reaches its physical boundary. Our ROV touches down softly on the abyssal plain. This is a massive, great desert of ancient silt and sediment that marks the bottom of the midwater void. And get this, it covers more than half the surface of our Earth. Down here we find a community of bottom feeders, scavengers, and deep-sea corals that meticulously work the sediments, relying 100% on the scraps falling from the world far above.
All of which leaves us with this final, genuinely provocative thought. As our ROV sits quietly in the silt on the deep-sea floor, you kind of have to ask yourself, what undiscovered monsters and mysteries still lie waiting in the Haddle trenches below? Because the abyssal plain is really just the start of the true bottom. The trenches plunge thousands of meters deeper still. We have quite literally only just scratched the surface of this alien world. It really makes you realize how much of our own planet remains a profound, beautiful mystery just waiting for us to explore.